is that, let me think, I don't know. Here, that is, if mu is less or equal than sigma, remember that the ordering of fuzzy sets is the pointwise ordering. That is, mu is increased in sigma if and only if at each point x the value of the function mu is less than the value of the function sigma, and this for all x in the ground set x. Okay, if this is true, then mu intersection lambda is less than sigma intersection lambda. Lambda intersection mu is less than lambda intersection sigma. The third axiom is if mu is less or equal than sigma, then mu plus lambda, this is for all lambda, for all fuzzy set lambda. In this case, if this is less than sigma plus lambda, lambda plus mu is less or equal to lambda plus sigma, the same. And the last axiom we need to suppose is that if mu is less than or equal than sigma, then the complement is less or equal to mu. With these four axioms, is enough to prove a lot of properties. Not commutativity, of course, not associativity, of course, not distributivity, of course, but we have a lot of properties. For example, we have a very curious property, that is this minimal algebra of fuzzy sets to verify the Kleen's law for any mu and sigma fuzzy sets. Always the intersection of mu with each complement is contained in the union of sigma and its complement. Then a lot of different properties follow from just all that. Of course, it is not supposed that this intersection and union and complement are functionally expressive. It is not supposed. The less supposed again is that this intersection is functionally expressible by a continuous, by a t-norm, nor the union expressible by a t-norm, nor the complement not expressed by a strong negation. This is not supposed. Then this minimal algebra of fuzzy sets is a very reduced number of axioms that nevertheless allows us to know which properties we have with just this. Okay. I will not consider this, but of course, here it is not supposed that this is mu0 and that this is mu1. Let me say that we always represent mu_r as the fuzzy sets that are constantly r. And mu0 is the fuzzy set that holds that only its only value is 0, and that mu1 is the fuzzy set which only value is 1. Of course, mu0 is the characteristic function of the empty set, and mu1 is the characteristic function of the full ground set. And this is not known here. This is not known. This is an open problem. This is an open problem. In which minimal theories of fuzzy sets we can have either principle of non-contradiction expressed in this way, or either the principle of excluded middle is expressed in this way. This is an open problem. The problem is closed in the particular case in which the intersection is made by a t-norm, continuous one, the union is given by a t-conorm, continuous one, and the complement, the not negation, is given by a strong negation. In this particular case, only in this particular case, we have a good result. The result is the following. this law, that is non-contradiction, holds if and only if T is in the family of Vukašević T norm, and the negation corresponding to this automorphism is greater than the given negation. This is if and only if. For example, you will have that principle in a theory in which T is, let me take identity, in norm of Vukašević, in which the given negation is less than the usual. Remember that the negation of the identity is 1 minus the identity. It's less than the usual negation. And the Tycho norm, any Tycho norm, here we have this nice result. This holds if and only if the S is the dual of Vukašević, the dual Tycho norm of Vukašević. And the negation is small, the negation is small than the negation given by this automorphism. Remember that a negation and phi is expressed in this way. Is for all order automorphism with interval, that is any strictly increasing function from 0, 1 to 0, 1, going from 0, 0 to 1, 1. Okay. These are not resolved because, of course, we will have both principles, both, as soon as we have T in the family of Vukašević, S in the family of the dual of Vukašević. And the negation should be, no, this is a mistake, sorry. And the negation should be encapsulated between the two negations given by the two automorphisms. Then this is a nice result. This is a nice result. Fine, okay. But this is a very partial result. We don't know more in this moment. Well, what I would like to try to explain you is the following. There is a different possibility of interpreting, of translating Aristotle's principles. And this is what I did with my colleagues Claudia Alsina and Ana Pradera a lot of years ago. The new way of translating is changing A and not A is impossible. Changing that by a different concept, that is, instead of impossible, I will replace self-contradictory. Self-contradictory. It's not more strange than translating impossible by false. It's something that is self-contradictory, cannot be. But we need to exclude. Why is this kind of translation? Look, in the case of ortholattices, if an object A is self-contradictory, that is, if A then not A and not A is self-contradictory if it happens. If A and not A, then not A and not A. This is the idea of self-contradiction. Something is self-contradictory when it's contradicted with itself. But if A, then not A. Okay? Yeah. In the case of ortholattices, this implies equal zero. But the only object that is self-contradictory in an ortholattice is but this is not the case, for example, in the Morgan algebras. For example, take the Morgan algebra.